We've used the perfluorinated compounds for over 50 years. They are extremely useful. We use them for waxing our skis. We use them for rain gear, for cookware in the kitchen. We use them to spray our sofas so that they don't stain. But the problem is that these compounds are also incredibly stable. So they break down only very, very slowly, also when we get them into the body. So when we absorb them, they stay inside for many years. Now, when these compounds started to be produced many years ago, nobody cared all that much about possible toxicity. And when chemicals legislation was enacted, then there was no requirement that the old chemicals had to be tested. And therefore, it's only recently that we have started to worry about these very stable compounds that enter the environment and maybe also the food chains. So we have been worrying about the perfluorinated compounds for quite a while. And last year, there was a mouse experiment published that showed that if the mother mouse had been exposed to these compounds, then the pups, the young from the pregnant female mouse, had deficient immune responses. And that even happened at very low exposures, so that the serum concentration, the blood level, was similar to what you and I have. So we thought, oh my, this may be really problematic. So we were already doing a study of about 600 children in the Faroe Islands in the North Atlantic between Iceland and Norway, a fishing community. And those children we had followed up until age 7. We had just completed that. And we had serum samples from various ages, and we also had a blood sample from the mother during pregnancy. So we looked for the perfluorinated compounds, and we found them in every single sample in this remote fishing community. All of them had perfluorinated compounds in them. And what we then did was to look at the immune response in the children in terms of the reaction to childhood vaccinations. And we looked at tetanus and diphtheria and measured the antibody concentration, the specific antibody against tetanus and diphtheria. And what we found was astonishing. We found that for these perfluorinated compounds, the higher the exposure, the lower the antibody concentration in the child. And at age 5, after the last booster, the child had been vaccinated 4 times. We found that it was primarily the mother's exposure during pregnancy that determined if the child was going to be deficient in terms of immune response. But when we looked at the immune function at age 7 and the antibody concentrations, we could see that it was the amount that the child had accumulated at age 5 that determined how efficient the antibody response was. And I mean, the baseline is that a doubling in the exposure was associated with a decrease of 50%. So it was a factor 2 increase, then it was in the exposure, it was associated with a factor 2 decrease. And this was quite serious because we could also see that some of the children were so low in antibody concentrations that they were essentially not protected. So they had been vaccinated 4 times, and the vaccines had not worked. And I think since vaccinations are so crucial for prevention in society, I think this is an effect that we have to take really seriously. So I think our study, which is it's a first of its kind, suggests that we have not done enough in regard to protecting the population against these old compounds, so to speak, because we haven't done the toxicology studies, we haven't done the monitoring we should have done, and now we're stuck because we all have them in our bodies. And we're all using them for when waxing the skis, and we have them in indoor dust, we have them in food chains, especially marine food chains. So I think that the US EPA and other authorities need to think about this and see if they can expedite the outphasing of the perfluorinated compounds.